Welcome to this revision walkthrough for question 1 of data mining and data warehousing. This is the compulsory question on the exam, worth 30 marks across 6 parts, and it covers everything from the basic definition of data mining, through the knowledge discovery process, mining functionalities, association rules, and a full entropy and information gain calculation. By the end of this session, you'll be able to answer every part of this question with confidence. Let's get into it. Before we dive in, let's look at the roadmap. Question 1 has 6 sub-questions. Part A worth 2 marks asks you to define data mining. Part B worth 6 marks asks you to describe the knowledge discovery process with a diagram. Part C worth 8 marks covers 4 data mining functionalities: characterization and discrimination, clustering, outlier analysis, and association. Part D worth 2 marks asks you to explain the association rule with an example. Part E worth 5 marks tests whether you can tell the difference between a data mining task and a simple data processing task. And Part F worth 7 marks is a calculation, working out entropy and information gain for a small dataset. Let's tackle each one in turn. Part A asks you to briefly explain the term data mining for 2 marks. Here's the definition you should know. Data mining is the non-trivial process of discovering valid, novel, potentially useful, and ultimately understandable patterns from large volumes of data. It sits at the intersection of statistics, machine learning, database systems, and pattern recognition. The core goal is to extract knowledge that supports decision-making, whether that's prediction, description, or both. Think of it this way: the input is large raw datasets and the output is patterns, rules, and models. Things like classification, clustering, association, regression, anomaly detection, and sequential patterns. Keep this definition tight and precise. Examiners are looking for those keywords: valid, novel, useful, and understandable. Part B is worth 6 marks and asks for the main steps in the knowledge discovery process with a diagram. This is important. Data mining is not the same thing as KDD. Data mining is actually just one step inside a bigger pipeline. There are 7 steps in total. Step 1 is data cleaning, removing noise, handling missing values, and fixing inconsistencies. Step 2 is data integration, combining multiple sources into one coherent store. Step 3 is data selection, retrieving only the data relevant to your task. Step 4 is data transformation, consolidating and aggregating the data into a form suitable for mining. Step 5 is data mining itself, applying algorithms to extract patterns. Step 6 is pattern evaluation, identifying which patterns are actually interesting using proper metrics. And Step 7 is knowledge presentation, visualizing or reporting the knowledge to the end user. If you're sketching the pipeline, picture it flowing like this: raw data, then pre-processed target data, then transformed data, then patterns, and finally knowledge. Remember the key insight: data mining is step 5 of 7. Everything before it prepares the data, and everything after it interprets what was found. Part C is worth 8 marks and asks you to describe 4 data mining functionalities using examples. First, characterization and discrimination. Characterization summarizes the general features of a target class, while discrimination contrasts one class against others, for example, profiling big spenders versus low spenders. Second, cluster analysis. This groups data objects so that objects within a cluster are similar to one another and dissimilar to objects in other clusters. It's unsupervised, for example, segmenting shoppers by their buying behavior. Third, outlier analysis. This finds data objects that deviate significantly from the general behavior, anomalies that simply don't fit the model, like detecting fraudulent credit card transactions. Fourth, association. This discovers co-occurrence relationships between items, the classic pattern of people who bought one item also buying another, like the market basket rule, where buying bread leads to buying butter. One distinction worth remembering for the exam: characterization, clustering, and association are descriptive. They find structure in the data. Classification and prediction, on the other hand, are predictive. They build a model to forecast future outcomes. Part D is worth 2 marks and asks you to explain the term association rule with an example. An association rule is an implication expression of the form X implies Y, where X is called the antecedent and Y is the consequent, and importantly, X and Y are disjoint item sets, meaning they don't overlap. Let's use a worked example from a supermarket basket. Bread and milk implies butter. In plain English, this means customers who buy bread and milk are likely to also buy butter. 2 measures matter here. Support is the fraction of all transactions that contain both the antecedent and the consequent together. Confidence is, among the transactions that already contain the antecedent, the proportion that also contain the consequent. These rules are practically used for shelf placement and cross-selling promotions, and they're typically mined from frequent item sets using algorithms like a priori or FP growth, filtered by minimum support and confidence thresholds. Part E is worth 5 marks, and this is where a lot of students lose easy marks. You're given 5 activities and asked to decide whether each one is a data mining task. The key test is this: does the activity discover patterns or build a model from data? If it's just a deterministic query, a sort, or a simple aggregation, it is not data mining. Let's go through them. First, dividing customers according to gender. This is not mining, it's a simple database query or partition, no pattern is discovered. Second, sorting a student database by student ID, also not mining, it's mechanical ordering of records. Third, predicting the outcome of tossing a fair pair of dice, not mining either because the outcomes follow known probability theory rather than a data-driven pattern. Fourth, predicting future stock prices from historical records. Yes, this is mining, it's predictive modeling and time series forecasting. And fifth, monitoring seismic waves for earthquake activity. Also, yes, this is mining because it involves anomaly and pattern detection in continuous sensor data. Here's a simple rule of thumb to carry into the exam. If a human or a line of SQL could write down the exact transformation by hand, it's just data processing. But if the relationship has to be learned from the data, it's data mining. Part F is the calculation section, worth 7 marks in total, and it's a favorite building block for decision tree questions using the ID3 algorithm. We're given a small dataset of X, Y pairs with a class label, made up of 9 rows in total, 5 positive and 4 negative. Let's start with part 1, the entropy of the class, worth 2 marks. The formula is info of D equals negative the sum of pi times log base 2 of pi here. The probability of positive is 5/9, and the probability of negative is 4/9. Plugging these in, info of D works out to approximately 0.991 bits. Now part 2, information gain, worth 5 marks. The formula is gain of A equals info of D minus info of A of D. Let's split on X first. When X equals true, we get 4 positives and 1 negative out of 5 rows. When X equals false, we get 1 positive and 3 negatives out of 4 rows. Working through the weighted entropy gives us an info of X of approximately 0.681, so the gain on X is 0.991 minus 0.681, which is approximately 0.310 bits. Now let's split on Y. When Y equals true, we get 2 positives and 2 negatives out of 4 rows. When Y equals false, we get 3 positives and 2 negatives out of 5 rows. This gives an info of Y of approximately 0.966, so the gain on Y is only about 0.025 bits. Since the gain on X is clearly larger than the gain on Y, the ID3 algorithm would choose attribute X as the root of the decision tree, because it reduces uncertainty about the class the most. Let's wrap up with the 6 key takeaways from question 1. Part A, data mining is about discovering valid, novel, and useful patterns from large datasets. Part B, the knowledge discovery process has 7 steps: clean, integrate, select, transform, mine, evaluate, and present. Part C, there are 4 functionalities to remember: characterization and discrimination, clustering, outlier analysis, and association. Part D, the association rule takes the form X implies Y, and it's measured using support and confidence. Part E, the mining test: if a pattern has to be learned from data, it's mining; if it's just sorting or a query, it isn't. And Part F, our entropy came out to approximately 0.991, with the gain on X at about 0.310, clearly beating the gain on Y at about 0.025, which makes X the root of the tree. One last exam tip before you go. Question 1 is compulsory, so it pays off to practice these definitions until they're automatic, be able to sketch the KDD diagram from memory, and rehearse the entropy and information gain algebra so you can do it quickly under time pressure. Good luck with your revision.